Alright, welcome to the C++ tutorial. Now today we're going to study or implement, so we're going to see about type conversion and yeah, type conversion. Now consider if you have say integer I equals 50 over here, but this isn't, if you want to say I have the same value which is of the float. Now what do you think the output will be? The thing is simple. Now since it is an integer, compiler assumes only 50. It won't display the 0.12 even if it is a float. So if you check it, here you go. It will only show you 50 until and unless there is no float over here. So this is the type conversion, or actually the C++ compiler is pretty smart. It automatically converts from one data type to another. Now there's another type of variables or data types coming is the const keyword. The const keyword is used specifically in specific conditions. Consider a case in which you don't want to change the variable's name or variable's value at all. So you just add a const keyword, indicates a constant value. So say if I want example, take the value of pi is 3.14. That's it. Now you don't want the value of pi changing in your program continuously, so you just add a const keyword to it. That's it. So the value of pi will never change out. Alright, value of pi is zero. Now there's a catch. If you try to change the value of pi now, if you try to change the value of pi now to 3.15f, the compiler will show an error. See the assignment of read only. Since we are at the word const over here, the compiler won't take any other values of pi now. Now using the const is another one. When I write short s, I'm making a declaration. That is, I have reserved some memory into my program, and then I can write down s equals to. Now at this moment, the box in or the register in the memory contains a garbage value. In this step, the garbage value is replaced by 2. This is perfectly alright. This is the mode of declaration. Like you go to int I, and then you fill out the values. So using the const keyword, it's not possible to first declare and then initialize. Here you're declaring and then pi equals 3.14. It's not possible over here. Using the const keyword. Oops. Right. So you see, here you cannot declare the variable. You need a dynamic initialization. That's it. So this is what we call it, a dynamic initialization. You're declaring it as well as you're initializing the variable at that moment only. Next we come to type definitions. Type definitions are symbolized as type def. Now we'll do an example. Consider you got unsigned long. Now I want to make some more unsigned long. Say unsigned long L, say AB, unsigned long AC, unsigned long A equals something number, similarly or something number, and there on. So if you say if like some 5 unsigned long numbers a b c a d having all those values differently. Now if you see, typing out unsigned long is quite tedious job. So that's where type definitions come. Type definitions provide a shortcut like. So you go for type type definition. What you want to give a synonym, or sorry, a prefix word long, and whatever prefix you want to give. So if you want to say that A B C, next time onwards, whatever you want to declare, what you want to initialize will be simply declared with the keyword A B C. So if you want to say A B C, whichever say I'm going to A B equals 10, then A B C A C equals 20. Now if you just print out the values, value of AB is, there you go. There you go now. Value of AB is 10, AC is 20. So that's the difference. You no need to type it on. So by default now, what this ABC indicates type def unsigned long ABC. So that's the advantage of not having to type out all of it. Alright, there you go, the drum roll. So yeah, that will be all for this tutorial.